Hello friends, welcome to your channel Electronics for You. Friends, let us solve one more problem of calculation of equivalent resistance using star delta transformation. So this is our lecture number 6. In our previous videos, I have explained the procedure regarding star delta transformation, delta to star transformation, and formulas regarding them, then how to calculate equivalent resistance, etc. So if you don't know anything about these contents, please watch our previous videos. You can see the link in the description. And here is our example number 2 of similar type. That is, in previous video I have taken some resistances of same values here, but in this case all the resistances are of a different value, and again we have to find RAB, that is equivalent resistance between point A and point B here, and by using delta to star transformation as well as star to delta transformation. So let us solve the problem by using delta to star transformation first, and later on we will see a star to delta transformation. This is our original circuit. Now as per our procedure, the first step is to identify the nodes, and therefore here I will identify the nodes, and now you can see node A and node B is already marked here. So we have to find further nodes. Now this one is the first node, you can see, and this one is the another node in this case, and this one actually is itself a B node, and therefore here I will label in the step 2 to these nodes, and therefore let it be C and D, and after step 2 we will get our network like this. Now next step is to redraw the network. Actually it is not a mandatory step, but if the circuit is complex you can simplify it by redrawing it. Okay, so in this case again A, B and C, D are our 4 nodes, and we have to use star delta as well as delta to star transformation to solve this particular network, and therefore I am redrawing this network like this. So after redrawing this circuit we will get network like this. Okay, now first we have to use delta to star transformation, and we have to find the equivalent resistance RAB here. Now in this case, as we are using delta to star transformation, first we have to find the delta network. Now as per the definition, a delta network is one which has 3 nodes and 3 resistance in between 3 nodes. Also they are forming a loop in between these 3 resistances. Now here you can identify the first node as this one. Okay, and you can see here that in between A, D and C 3 resistances are there, and they are forming a loop. Similarly, this is another node B, and here again it is forming a loop between these 3 resistances of 4, 7 and 10 ohm respectively. Okay, so here basically 2 delta networks are there. We have to solve only one delta network if 2 delta networks are given. So I will use this delta network to simplify. This means 8, 7 and 3 ohm resistances. So I will require one star node here at the center, and further I will connect 3 resistances between these 3 points, 3 nodes, and therefore step number 5, convert delta to star like this. Okay, now this part is actually drawn by pencil. Further we will remove it once the replacement is done. Now as we are converting the delta into star network, here we should use these formulas. Now delta to star transformation, here the formulas are like this. Now this delta network is converted into this star network. How this is converted? So by using the formula here, look at this. For this node, means I am converting this delta into this star network, and this resistance is having this formula, where this node is actually showing is directly connected to R1 and R3 here. So R1 and R3 in multiplication in numerator divided by sum of all the resistances in denominator. Here also for this resistance, equivalent resistance, here this node is actually connected to R1 as well as R2. R1 into R2 in numerator divided by R1 plus R3 in R1 plus R2 plus R3 in denominator. Same concept will be used to solve these resistances. So let us solve this resistance first. Let it be RA. Okay, now RA, you can call it as RAE also, considering this E as a neutral point. Okay, so RA here equal to, now at this node, this 8 ohm and 3 ohm resistances are directly connected. So in numerator their multiplication is there and sum of all the resistances connected in delta. So 8, 7 and 3. 8, 7 and 3 will be added here. Similarly, to calculate RD, that is this resistance basically, RD equal to, at D 8 and 7 ohm resistances are directly connected. So 8 multiplied by 7 divided by 8 plus 7 plus 3, that is all the resistances in delta. Now for this third resistance, let it be RC here. Okay, RC will be equal to, now to this C node, a 7 ohm and a 3 ohm resistance are connected. Therefore 8 multiplied by 3 in numerator upon 8 plus 7 plus 3, and after solving this we will get this value. So now a delta network is converted into star, so I can remove these delta resistances here, and therefore our network will look like this. And in this case, now further we can solve a series parallel combination of resistances. So we have to find whether there is a series or parallel combination or not. Now in this case you can clearly see that this EC and CB resistances, these two resistances are in series, as well as these two resistances, that is ED and DB. These two resistances are also in series, and therefore I can say that solving resistances in series in this case. Okay, and if I solve this, definitely for series the sum will be the output, and therefore this plus this resistance means 1.167 plus 4 ohm resistance will provide output as 5.167. Similarly, 10 plus 3.111 will provide 13.111. Now this and this. Okay, now these two resistances can be replaced by a single resistance, and therefore the network will be converted into this network. Okay, now you can clearly see that these two resistances are in parallel because they are connected across node E and B here, and therefore here by using a parallel resistance formula, that is multiplication in numerator and sum in denominator. So REB equal to 3.706. Now these two resistances can be replaced by a single resistance like this, and therefore further these two resistances are in series, and therefore they will get added and provide output as RAB equal to 5.039. and in this way we can solve we can find an equivalent resistance by using delta to star transformation in this case. Okay, now let us solve the problem by using star to delta transformation, and in this case again I will use the third step here, that is redrawn circuit. Only case was this A was shown here as well as this B was shown here, but it's okay. Now we will find a star network because we are using a star to delta transformation. Therefore in this case again for the same network you can see this star network there. A star network is one where three resistances are connected to a single point. That single point is actually called as star point or a neutral point. Okay, one more star point is there, and this is this one, C point, and three resistances are also connected there. But I am using these three resistances here, and I will use a star to delta transformation for these resistances. Therefore I can draw three resistances to these 3 points like this. Okay, and therefore my circuit, my network will be converted into this network. And now I can use a star to delta transformation formula. The formula for star to delta transformation is given here. Now a star network can be converted into a delta network. Now for this equivalent resistance formula, here you can see that in between these two nodes this resistance is here, and therefore these two resistances will be first added, plus multiplication in numerator, their multiplication in numerator, that is R1 into R2 divided by third resistance, that is R3. Same formula will be applicable in this case also. So these two resistances will get added, plus their multiplication in numerator divided by third resistance R1. Okay, the same concept can be used here to calculate the value of RAB, as this resistance is connected between AB, and 8 and 10 ohm resistances are there. So 8 plus 10 plus 8 multiplied by 10 upon third resistance, that is 7. Similarly, this resistance can be calculated by using formula. Let it be RBC equal to, okay, now in between B and C, 7 and 10 ohm resistance is there. So 7 plus 10 plus 7 multiplied by 10 upon third resistance of 8 ohm. Similarly, this resistance, now it's very easy, that is RAC equal to 8 plus 7 plus 8 times 7 upon third resistance of 10 ohm. Now you use calculator and find the equivalent value, you will get this. Now as we have drawn the delta network, further I can remove this star network. So overall the network look like this, and after step number 5 we will get this combination. Now for next step, as we have already used a star to delta transformation, further we can solve it by using series or parallel resistances. Now in this case, in between A and C, a 20.6 ohm resistance is connected. Also in between A and C, a 3 ohm resistance is connected. Means these two resistances are in parallel. Similarly, these two resistances are also in parallel, and therefore we can use the formula for solving series solving resistances in parallel. And if I solve it, definitely here the multiplication of these two in numerator divided by their addition, and therefore we will get 2.619. Similarly, in this case a 4 point, we will get 3.462 as RBC. Now these two resistances can be replaced by a single resistance. Similarly, these two resistances can also be replaced by a single resistances of this and this value respectively, and therefore we'll get equivalent circuit like this. Now in between AC and CB, you can clearly see that these two resistances are in series, and therefore they will get added, and therefore RAB means for these two resistances only, it is equals to 6.081. Now these two resistances can be replaced by a single resistance of this value 6.081, and therefore now you can clearly see that in between AB both resistances are connected, means they are connected across each other. Therefore we can solve resistances in parallel there. And now the calculation, after calculation we will get output resistance RAB, equivalent resistance RAB equal to 5.039. Now again note that in this case also equivalent resistance is found to be 5.039, and for previous case also it was 5.039, because equivalent resistance will always remain same whether you whatever the method you are using. You can use series parallel resistances, you can use star delta transformation, but overall equivalent resistance will always remain same. And in this case also we got the same answer, means we got the correct one. Okay, so friends, if you like this video, please subscribe our channel and share it with your friend. Thank you.